So 2021, paper 1, question 2, A and B. So given that x is equal to minus 3, is a solution to the absolute value of x plus p equals 5. Find the two values of p, where p is an element of z. Okay, so we've come across this absolute value before, and the method we normally use, well, you can look at it in two ways. You can say that because it's absolute value, there is a possibility that it's originally positive or negative, so that it generates two answers. But I suppose the easy way around it is if you square both sides, then you're doing away really with the mystery around the signs. So for that reason, I'm sorry, I know what x is as well, so I'm going to replace the x. I'm told that x is minus 3. So I'm going to put minus 3 plus, I'm squaring it, and when I square 5, 9 squared, and I might as well bring a squared minus 6p. Now I have 9 equals 0. So now all I have to do, it's two values of p. So I'm happy to see a quadratic there. So I guess I'll just do my factorization and my null factor theorem. So in other words, I'll just get my factors first. Now, because it's minus here, I'm expecting the signs to be different, 1 plus 1 minus. Factors of 16, so I guess 8 and 2 works, doesn't it? 2 here and 8 here. So if I do my smiley face check, 2p. Okay, so I'm nearly there. Now you can use the minus b formula instead if you want, but if it's a kind of an easy enough one like this one, I would just do this method. So p is either minus factor. Now that's always a really powerful phrase, is a factor. That means that if you were to divide this in, you should have no remainder. So even before I read the rest of the question, this I know that if I do long division on this, there should be no remainder. Now, it says show that q is minus 5 and find the three roots. So I'm hoping that it will just naturally happen. It should naturally happen that when I do my long division on this, I should end up finding out that q is minus 5. And these questions are always good because even if you get stuck with this part, you now know that q is minus 5, so you can finish the question, even if you couldn't do the proving part. So anyway, we'll hopefully be able to work it out okay here, and then we'll be able to get the roots eventually. And it's 3 roots because it's a cubic. So quadratics have 2 roots, linears have 1 root, and the cubics have 3. So the power tells us the root, basically. Power of 2, 2 roots, power of 3, 3 roots. Okay, so we start off and we say, how can I make an x into an x cubed? Well, I need an x squared multiplied back. X squared by x is x cubed. X squared by 4 is 4x squared. Now, usually we change the signs across, or we can say it in a better way, multiply across by minus 1, but we just need the signs to be opposite so they cancel. Now, I'm just going to write this in a bracket. So q minus 4, and I'm going to put the x squared outside just to kind of group it together. And then I normally, of course, drop down the next term, and we do the whole process again. So I start and I say, okay, so how can I make x into q minus 4x squared? Well, I would need a q minus 4x, multiply that back. So that's going to be q minus 4x squared. Just be careful here now because you have to multiply it here as well. So plus 4x, I'm just going to put the 4 and the x next to each other, q minus 4. Now, when I go to change the signs across, we just have to concentrate here. This is minus, and this is going to be minus. They cancel. Now, what's left? Well, there's a minus 22x. There's a minus 4x bracket q minus 4. And then, of course, we're going to have to drop down the remaining 56. Now, before we do any more, we should just tidy this up a little bit, because when we go to finish the long division, we need all the x's to be kind of together. So before I continue, I'm just going to tidy this up a little bit. Minus 4qx plus 16x, and then the plus 56 at the end. Okay, so minus 22 plus 16. So what's that? That's minus 6x. So minus 6 minus 4qx plus 56. So what I've done there is I've pieced together the minus 22 and the 16. So that's minus 6x. And then because I'm putting it with minus 4qx, I'm just basically leaving the x out and I'm just grouping together the terms. So now if I go back once again and I say to myself, okay, how can I make this x into a minus 6 minus 4qx? Well, clearly what I need is this plus minus 6 minus 4q, multiply back. So multiply him right back again, minus 6 minus 4qx. But don't forget to multiply by the second guy. So you need to multiply by 4 as well, bracket minus 6 minus 4q. Okay, we change our signs across, minus, minus. They cancel. Now, hopefully we get what we need here. So we're left with a 56. Now, minus 4 by minus 6 is plus 24. Minus 4 by minus 4q is plus 16q. Now, this is supposed to be equal to 0. Remember, there is supposed to be no remainder. So if that is the case, we let it equal to 0 because we're told that it is a factor. So there should be no remainder. So 56 and 24 is 80, isn't it? Yeah, 80. So if I move that over, I get minus 80. And then when I get q on its own, minus 80 divided by 16. So is that going to give us what we're looking for? It does. So q is minus 5. So that's the first bit done. Show that q is minus 5. I've done that. Now, find the 3 roots. So what are the 3 solutions? Now, I wouldn't like to have to go through too much of a painful process again because I have a lot of the work done. So I think what I'll do is I'll start by saying, well, if x plus 4 is a factor, then x equals minus 4. So that has to be one solution. Now, that's one factor. The other factor is, well, the other factor is what I have on the top line, x squared plus, I'll just rewrite it, q minus 4 bracket x plus minus 6 minus 4q. Now, so just to clarify that, like if I was dividing 4 into 12, the answer here would be 3. So what we're basically saying is if that's a factor, that's a factor. So that's what I did here. I said, well, if that's a factor, the solution's minus 4, but this also is a factor. So that's what I've written here. Now I have the advantage of knowing that q is minus 5. So what I'm going to do is I'm going to replace q with minus 5. And that should help us even further. So that's x squared minus 9x. Now, what's this? This is minus 6, isn't it? Plus 20. So that's 14, isn't it? Minus, yeah, that's 14. Now, this should be an easy enough one to solve. Again, because it's quite easy, I'm just going to do my factorization and my null factor theorem. The plus means they're both going to be the same, both minus because he's minus. And then I guess 7 and 2, isn't it? Is going to work. So x is 7 and x is 2. So they're my 3. I'll just highlight them so it's clear. So I now have my 3 solutions here, here, and here.